be equals to, okay, so acceleration will be equals to v square minus u square divided by 2s. Now you can put the value of acceleration here, v square minus u square divided by 2s, and afterward work done is equal to force into displacement. Just put the value of force and displacement will be cancelled out and you will get this value. This answer will be there. Okay, so that was kinetic energy. And if initially body will be at rest, then kinetic energy formula will be half mv square and u will be equals to 0. U will be equals to 0. Okay, fine. So let us begin with our today's topic. That is potential energy. Potential energy is basically the energy that is possessed by the virtue of position. We can write, let me write with blue markers so that many of the words are there and you can just go through by it. Position, configuration, shape, height, if I will place this marker, then its position is changed. That position is basically related to the energy that will be called as potential energy. So potential energy is the energy that is possessed by the virtue of position, configuration, shape, and height of the object. Okay, fine. What will be the difference that I will show you in virtual session today? That what is the difference between kinetic and potential energy? Okay, so let us start with the derivation. What is the derivation? See, I have taken one object and you all know object's weight is in gravitation. We all have done weight is actually a force which is equal to mass into acceleration due to gravity and always acts in downward direction. So weight is mg, and from this height, from this point to this point, I have placed this object. So this means at some height I have placed. So let us start doing. What is there? We need to find potential energy, and potential energy is equals to work, and that is equals to force into displacement. We all know in positive work done is equals to Fs cos 0. Cos 0 is equals to 1. So W is equals to Fs, isn't it? So the formula of W is mg. What is F? How much of the displacement here it has covered? Write through chat. I'm waiting for your answer. How much of the displacement this block has covered from A to B in this diagram? H. Very good. 2 students have given good. Kiran good, Shubh good, Bhavya, Shreya, everybody's answer is correct. So displacement here is H. Very good. So potential energy is equals to mgh. Very simple derivation for it. No derivation, even we can say this. Okay, one more thing I wanted to ask. If suppose here it is not 0, it is not ground level. It is H1 and above point is H2. Then what will be the potential energy? Who will just let me know? Write through chat if you know the answer. I'm waiting for your answer. Then what will be the potential energy? H1 minus H2 should cover. H1 is the lowest point, beta. H2 minus H1. Now fine. Who has given answer? I guess. Yes, fine. Now fine. Vanshika also is giving answer. Vaishnavi Gupta, fine. Ashish, good. Everybody is good. Now, so answer will be mg H2 minus H1. Higher point minus lower point you need to take. Don't take lower to higher because answer will be in negative otherwise. Okay. So H2 minus H1. Fine. Correct. Now what is the SI unit of potential energy? SI unit of potential energy. Joule. Same units will be there. Very good, everybody. Please, rest of the students, those who are not giving answers, please be aware, be respondent. Yes, Ocean, good. First answer today you have given. In CGS, it will be ergs. Very good, Amandeep. Okay, so SI unit is Joule. That's all about the kinetic energy and potential energy. Okay, fine. Now let us discuss one or two examples of potential energy, where potential energy is possessed. Who will give answer? Raise your hand for this though. I'll not read from the chat box. Let's raise your hand. How many students will give answer for this? Okay, from Florence I got Anshul Lathar. Only one hand. Anshul, okay. I have allowed you. Unmute.
Good morning, ma'am.
Yeah, good morning, my kid. Let me know.
Ma'am, water that is behind a dam.
Very good. So good. Good example. Okay. Mute yourself. So water that is behind the dam, that is at some height, so it will possess potential energy. Very good example. Okay, Ayushi also wanted to give answer. So Latika, only 4 students. Bad it is. Shubh cover, fine. Okay, let me give chance to Shubh, then Ayushi. Yes, Shubh.
Good morning, ma'am.
Good morning, Nikhil.
Ma'am, if a helical spring is either compressed or stretched,
Today your voice is coming very slow. Shubh. Okay, no problem. You have muted yourself. No problem. Ayushi, okay? Unmute.
Good morning, ma'am.
Yeah. Let me know quickly.
Ma'am, a stone lying on the roof of the building has the potential energy due to its height.
Okay, fine, good, nice. So a stone is lying somewhere at some height. So we can say that it is a very good example of potential energy possessed by any of the object. Good. Helical spring got the Shubh cover. I got that helical spring you were saying, but your voice was not that much audible. Okay, so all answers are correct. Potential energy can be possessed. Even you can say that spring, if you extend spring, car parked, very good, Gurpreet, bow and arrow, very good example. Okay, I show you in virtual session also, but let me know, suppose we are having one spring bow. Okay, like this. One spring bow is there. Okay, and here bird is there. Angry Bird game was there once we used to play. So when we will just stretch it and it will go to hit houses. So let me know here at this point which energy, and while moving, which energy will be possessed by it. At point A, which energy will be there, and while moving, which energy it will possess. Write through chat quickly. Let me know. Potential energy, Amrit Singh Chima, okay. Good, very nice. Potential energy, very good. Everybody's answer is correct. Sukhman, at last you have given answer. And while going back, potential energy again, Nikhil, no. While going back, why? When it will be traveling. Yes, Shreya's answer is correct. Sukhman answer is correct. When it will be traveling, beta, it will be in motion. So it will be moving. This means at that time, kinetic energy will be possessed by it. Okay. So this means that here potential energy, and then that potential energy get changed, get transformed into kinetic energy. Okay. Got that? Very good. Correct. Fine. So now let us talk about the transformations of energy. See, there are many transformations of energy as you switch on the light at your home, so that electrical energy gets changed into the light energy, isn't it? Suppose from windmills you generate electricity. So wind energy get transformed into the electrical energy. So many examples are there for transformation. What did you understand from transformation means conversion from one form of energy to another form of energy. Fine, that is known as transformation. But if we talk about physics chapter that we are talking about, then how can we say some of the energy? So I have made one pendulum for it. Very simple pendulum. Let's see how many type of transformations it will show. Okay, so this is my A point, this B is mean point, and this C is extreme. You all know center point is mean and rest of the two extreme points are there. So if, okay, very good, Amrit. I got your answer, good. So what I was saying, if I will pull this bob from mean position to extreme position, one of the left hand extreme position, then which energy it will possess? Who will let me know? Write through chat quickly. At point A, it will possess, very good potential, Sukman, good Shubh. Yes, so it will possess potential energy because it will be at some height. Very good. So it will possess potential energy. The moment I will leave this, the moment from this point, I will just leave this. Then which energy will come? Kinetic energy. Very good, Ashish Kumar. Very good. All of you giving correct answer. Good, Kanika, Nikhil. Good answers. Yes. Then the moment I leave this, it will come to kinetic energy. Then let me know at mean point. At mean point, kinetic energy will be maximum or potential energy will be maximum. Which energy will be maximum? Kinetic energy. Yes, very good. No one, Amrit Singh, wrong. How no one? It is moving here. It is moving here. So kinetic energy will be maximum and potential energy will be minimum over here. Then again, it will go to another extreme point. Again, it will be at some height. So here again, potential energy will come and potential energy will be the maximum energy here also. At extremes, potential energy will be maximum. And then slowly, steadily, it will cover kinetic potential, back to back. These same type of energies will be coming. And at extreme, potential energy will be maximum. And at mean, which energy will be maximum? Kinetic energy will be maximum. So many transformations are there. Okay. One more thing, beta. Yes, in yesterday's topic, one graph was left for kinetic energy versus mass. So let me tell you that. Afterwards, we will go for virtual session that what is the difference between kinetic and potential. Okay. So we will recapitulate that also. Okay. So first is kinetic energy. I have taken on y-axis, you all can see. And in one graph, I have taken mass. And in another graph, I have taken velocity. So for kinetic energy and mass, they both are directly proportional. And many of the times, let me see, ma'am. Who is Netik? Netik, ma'am, I guess Netik is in Florence. So Netik, beta, I am removing you. Otherwise, write proper ID. From which section you are there. Otherwise, I'll remove you. Or text me that, ma'am, this is the problem. That is why I have entered like. Otherwise, within 10 seconds, I'll remove you. So kinetic energy versus mass, we all know kinetic energy is directly proportional to mass. So it should be, I checked, it is not there in any section. Okay, ma'am, let me remove. Very good, beta. Why you are entering like this? I have removed, ma'am. Okay, fine. So now continue with our topic. So kinetic energy is directly proportional to mass. So kinetic energy, if is directly proportional to mass, then kinetic energy is directly proportional to mass. So inclined straight line is there. And if we talk about kinetic energy and velocity, then which graph will be there? Who will tell? Right through chat. I'll not make. How kinetic energy depends on velocity? Quickly write. Then we need to go for a very good curve. Very good. Curve path will be there. Why curve path will be there? Let me know the answer. Very good, Ashish. You both have given correct answer. Amrit, good. Bhavya, Nachiket, good. But why curve? Why curve path? Shaurya, Kansal, good. Quickly. Proportional to the square of the velocity. It is not dependent directly on first power, it depends on second power. That is why kinetic energy is directly proportional to the v square. That is why this curve path is coming. Okay, fine. I hope you got this point. So up to here we have completed. Tomorrow we will be continuing with conservation of energy, our last topic of the chapter. Firstly, let us do one numerical. Afterwards we will have virtual session. Okay, so let me tell you statement. Start writing quickly. The mass of the body is 64 kg. Mass of the body is 64 kg and it is at 40 centimeters. It is at 40 centimeters. Then how much of the potential energy it will possess? Solve it quickly. How much of the potential energy it will possess? Let me see how many students are solving. I'm on screen checking you guys. G value you need to take good by yourself. 256. Joule, Nikhil has given answer. Let us see what is the answer of others. Okay, Ocean. Let me see for others. Good, and Ragnotial. Very good. Good. Everybody is giving answer 256. So let me also solve what is the correct answer. So potential energy is equals to mgh. Mass I have given 64. G we all know is 10 or 9.8. You can take anything. And H height I have given 40 centimeters. So you need to convert it. So divided by 100. 1 0 will be cancelled. This 0 will also be cancelled. So answer will be 64 multiply 4. That is 256 joules. Very good. Very nice. Great. Okay. So now I'm telling you that I'm showing you one video. That is the virtual session. That what is the difference between kinetic energy and potential energy? Latika, you want to ask something? Okay, unmute. No, fine. Okay, so everybody's camera should be on firstly. Ansh Verma, Ayushi, what is there? I'm looking at you guys. Anurag from 9th Florence, another Anurag, I know that. Please switch on your videos, everybody, quickly. Daljit, Dev Sharma, Jyot, you are late, very late today. Garpreet, Gunjit, switch on your videos, everyone. Mayank, never ever will be doing. Let me just remove you from grade. I am removing you, Mayank. Now fine. It has to be switch on only. Otherwise, Seema ma'am, do not give attendance to him. Mayank from 9th Florence also. Okay, so let me begin with the virtual session. Okay, so let me start sharing screen. You all will find it very interesting. It is good. Okay, so let me show you. So I can't help in this. YouTube always used to give ads. So I can't help in this. Just wait for 10 seconds. It will be over. Yes, begin. See, what is the topic? Difference between kinetic energy. Here, a lady is just carrying a basketball and she has thrown it up. So we all know she has given motion. So energy possessed by it will be kinetic energy. Isn't it? So kinetic energy is due to the motion of the body. As car is also moving, this aeroplane is moving. So energy possessed by both of these are also kinetic energy. See, two mans are walking. One is running, another one is walking. So faster body moves with from the ground. It was at some height. So position is there, height is there. Above, kinetic energy will be zero. And then the moment she will fall it, kinetic energy will be there because motion will be there. But where this work comes from potential energy, because it was at some position, at some height. Okay, so now one more closer look she is giving at some height. Look, so she has fallen. This means at a point potential energy, the moment it started to move, it was having kinetic energy. Okay, so higher the goal, larger will be the potential energy, because potential energy is directly proportional to height of the object. We all know. Yes, now see Angry Bird example I was telling you. It was in Springbow, and this bird is possessing potential energy. We have done this example now only. In the moment I will leave this, it will just break all the houses, and that will be converted into kinetic energy because that position will be changed into motion. So let us do one exercise. Who has the greatest potential energy? Three are there. So the, yes, bubble is at most of the height, at the highest point. So this means potential energy will be more because height is directly proportional. So let us summarize. Energy due to position is potential energy. Energy due to motion is kinetic energy. We all know if height increases, potential energy will also increase from the ground if we talk about. And if velocity increases, then kinetic energy will also increase. We all know this. So how did you find this? Did you get what is the difference between kinetic energy and potential energy, everybody? Write through chat. If even now you have any problem, any doubt, then you may arise your question. Interesting, ma'am. Yellow, you have given answer, Vanshira, very good. Yellow bubble, very good. It possessed highest potential energy. Very nice, Shreya. Okay, you find it interesting. Good, interesting. Everybody is saying it was great. So my main motto was this only, beta. Sure, console. Okay, got this. that you should not be like in any of the trouble that ma'am, where which type of energy will be there, what is the difference. So now you all are aware of this, isn't it? So that was very good. I'm also very happy that you all understood this. Fine. Now, what I wanted to say, beta, today you'll be getting again NCRT. You need to complete all in-text question answers. Fine. You will be revising, and the numericals related to these topics you all will be revising. Fine. Second point, what you all will do? Ayushi, I'll be giving you chance. Wait a minute. So, second, what you will be asking, sorry. Second, that you all need to go through by the online videos. If anything is left, suppose your network connection was not good or any problem was there yesterday, as if Ayushi was not there. So I'll be sharing two of the links also, yesterday's class as well as today's class, so you all can go through by it. Okay. Third, we all have completed notebooks already, but what you all need to do, that you need to do practice of the numericals covered up to now, means up to potential energy. So we will be doing all the potential energies, numerical, extra numericals on Friday. Thursday we will be covering up, like tomorrow we will be covering up all work. One topic is left, that is conservation of energy. Okay, so conservation of energy will be covering up tomorrow, and numericals also related to it. I'll also show one more virtual session tomorrow as well, so that doubts become more clear and all concepts should be clear to you. Okay, fine. Any doubt now? Ma'am, in text question, we have to write in fair notebook. Yes, Sanprit beta, you need to write. If we have completed already, I guess we all have completed already. So there is no need to write it again. Yes, Anurag Notial, no doubt. Very good, Ayushi, no doubt. So yes, ma'am, already done. So there is no need to write again. I'm just saying to do it in practice notebook. Okay, fine. So goodbye for the day. We will meet tomorrow again, and I hope you